tank. This needs to be on the supply side of the boiler. The reason for that is less of a reason these days than it used to be. Back in the days when they were air tanks, the ones that would hang up on the top of the ceiling, if you had it on the negative side of the pump, you would end up usually sucking air out of it. Because it was full of air on top, and you would start sucking air out of the tank, you know. You typically would want to, but let's always try to put it on the supply. They're meant to be on the supply side. Okay. Also, the reason you do want to have it on the supply side is this tank is meant to counter pressure increases, and the supply pipe is hotter. It's post the boiler, so it'll react faster to a pressure change. You all know pressure and temperature are directly related. When the temperature starts going up in the boiler, so does the pressure, and this is here to literally counter that, because the pressure in your system remains the same until you start heating up the water. And this tank is half water, half air, with a bladder inside. Once this water starts getting hotter, it'll start pressing against the air side of the tank, and the air will give a little. It'll allow the membrane to move down to equalize the pressure. Whenever you guys see these boilers running, you're always going to see some of them have the pressure on the display, and you're going to see it like climbing. Do you remember how you and I were flushing over on Greenwood, and we were actually getting the pressure up in order for us to flush things out? It was a digital display of the pressure. Most of these boilers now are pressure sensitive. They won't operate unless you have 14 pounds of pressure. Not even 12. They want 14 pounds of pressure. I don't know why, because we've always been taught to do 12 pounds of pressure, but they give you a fault if you're under 14. Yeah, so they give you a fault. And they basically, they shut themselves down, and you get a digital readout that says feed. Like it's feeding water. It's waiting for water to feed in.
It thinks it's low.
It thinks that it's low. On these boilers too, actually I'm going to probably turn it on because I leave this separated so you guys can see what it's, at least what the display is, because this is the boiler that we sell a lot, or at least the control is. So things will make sense to you. There's a couple of things to know. Very important thing that I learned, when there's a reset button on it. If the boiler asks you to reset, click it quickly. One click and let it go. If you're gonna hold on to it, it thinks you're trying to get into 5-second reset menu.
Yeah, 5 seconds is something different than just a 1 second thing.
If you do have to end up resetting it, it's warming up very slowly. So tick tick tick. And once it shows up, you see these are nice boilers because they make it pretty clear. You see there's a faucet for hot water heating, for like domestic hot water heating, and there's a radiator for heating up the house. If something is on, this radiator will be encased inside of like a rectangle. Or if there's a call for hot water, same thing here. It'll be a rectangle. If you're using this thing for hot water, there's a separate pipe that returns the water from either a storage tank or usually a storage tank. You know, so be familiar with that. Remember, there's a difficult menu to get into, but if you have to, and it's a 3-digit menu on there. There's three sets of numbers that you have to hit in order for you to make any changes on the menu. And if you do have to start up, it can be that Tom is starting up everyone's boilers, you know, because I remember Tom learned this like a while back about the 3-digit thing. So, but you know, honestly, quickly, this gives you can adjust the temperature of where you want the water to be coming out of the boiler for hot water heating. Maximum is 180 or 179. That's for radiators. These high efficiency boilers are not any good for copper fin tube. They don't give you enough heat. You need 190 to 200 degrees for that. So you need a cast iron boiler for the radiators you installed in my cousin's house. This boiler cannot work there because the water would be too cold. You gotta have a cast iron old school boiler. If you're trying to heat up, floor heated like radiant, you want 120 degrees. If you're trying to heat up a Unico coil, 140 to 160. So remember those temperatures, you know. And this gives you, you know, on this side, if you, now it doesn't want to do it, but you can also change the temperature of the water that you want coming out of here too, you know, if you're just trying to heat up, you know, a storage tank. So that's about it, guys, you know.
What temperature would that be to heat up the storage tank?
So if you're trying to heat up a storage tank itself, you want maximum 180 degrees, you know, because then that storage tank will have its own temperature read and it'll shut the boiler off when it's 135 or 140 inside the storage tank. If this is a combi boiler, which this one isn't, where you have a heat exchanger.
Right?
So
Yeah.
combi is,
Combi,
you don't need
yeah.
a storage tank. You just bring cold water into this and hot water comes right out through a plate heat exchanger. Then this digital display will tell you what the temperature water you want going into the faucet, which should never be more than 140. That's your max, because that's scalding temperature. So 140 is your max, you know. But if you're heating a storage tank, which is what we normally would do,
It always
then you want to max
defaults
it.
to going. It defaults to going to max anyway.
Yeah,
You
unless you change
Do
it.
we need
Yeah.
the storage tank for the combi one?
No, if you have a combi, so basically
Combi is like you have a tankless water heater in the boiler as well.
yeah,
But like couple faucets gonna be open.
combi's bad for that.
That's it. You
Yeah.
have to have the storage
You have
tank.
to have the storage. Is what
Whereas-
she's saying.
Question?
Yeah, so what type of boilers do we have? Is the combi one, what else?
Okay, the type of boilers that we installed, yes. So typically, this is a standard boiler that you can have, if you look in here, it has two functions. Either circulates for hot water heating, the radiators, or inside here's got a valve that allows the water to come from here into a storage tank. So this boiler can do hot water heating and a storage tank. There's also a combi boiler that has a heat exchanger built inside already, where you bring cold water, as if you did for the water heater on top, cold water pipe in, hot water into the faucets. That's a combi. There's really only two types, Taras.
Okay.
Oh, man. For some reason I thought you
They
were
don't look the same. That's what it said.
So there are only two types. There's a combi, or there's the one that can direct. There used to be older boilers didn't have this, but now everyone's doing this. Back in the back in the days of 10 to 15 years ago, you only had a boiler that you had to put your own pump in and circulate through here, and then you had to set a second set of pumps to go into. Like back in my house, do you guys remember how I had an extra pump just to my storage tank? That doesn't have to happen anymore because they put this in for you. You know.
That's nice.
So and then after this, I want Isaac, you know, Richie, the young guys. Where's my kid? Matt, you know, Sam, you're gonna be watching it. Eric, the young boys. I want you guys now to disassemble this thing to tiniest pieces. Okay, the older guys don't need to do this, but the young guys have to do that.
Take put that pump, Isaac.
I got one thing I want to say real quick about the closely spaced set of T's. They must be in this configuration. This does not count as a closely spaced set of T's. This will just bypass this completely and not even do it. So you do want to actually have these as a separate.
And we need
I see that set
that
up
for
so many
all
times, the
high
other way.
efficiency.
Really?
This is not going to do shit. This
Yeah.
is gonna-
everywhere.
This is if you didn't even have it.
Just for that, this will work like this.
One.
That will
Yeah,
work.
well, but this is the best.
So this is for sure the best. It's easy to remember. It's about this T.
Yeah.
It's not about this one. It's about this T.
Yeah.
This T has to be like this.
Yeah.
You know, it doesn't work because
It'll
otherwise
just flow right through and not
Exactly.
mix.
This is where that needs to be like this. Here it's not relevant because if you do this, you're still gonna mix from the top and down. Just so you know, because sometimes you may not have the ability to do
Right.
that. Right?
Right. Yeah. And you can also, I mean, if you don't have space below, you can always pipe over, and I've done it like that.
Yeah. It
Or
doesn't
even
have
if
to
you're
be
going
here.
up.
Right.
Yeah, it doesn't have to be there, but that's the easiest configuration.
But maybe I shouldn't confuse you guys. Listen to Tom. You always do this. You'll never have a problem, you know? But this is the most important thing. This T has to be like this. Because if you put this T like this, you know what's gonna happen? The water's gonna go right to the boiler. And no water is gonna wanna go here.
And this is only on high efficiency boilers.
Yeah. Trust me,
And a
they're
cast
only-
iron, you don't have the primary, secondary. It's just the supply going straight to the supply, return going straight to the return.
But just be aware of this, Isaac. I don't think in your career you're gonna see a lot of cast iron boilers anymore.
Bring back cast iron borders.
I mean, it's like you gotta. There's gonna be a few applications where they're needed, and really just the fin tube radiators, and that's only apartments. Otherwise, all new installations that we know of, you're doing radiant, you're doing snow melt, you're
High
doing
efficiency.
high efficiency equipment. You know, there's not gonna be a lot of cast iron boilers to be put in. Even replacements, you notice we're doing just a lot of
Still
it.
important to understand. And then on cast iron's another thing. This system pump or the boiler loop pump, that's usually you'll see them right on the off the return, sucking towards the boiler. On the old school systems, then you'll see the zone pumps when they branch out on the supply, oftentimes.
And for
That's
that,
the
maybe we
classic.
take pictures. Like maybe we're not gonna put one of these here, but
No,
maybe take
but
pictures
that's a
and
classic
talk about
setup that you'll see a lot in service.
it. We can always take a lot of pictures and always talk about it, so you guys can get comfortable. with it.
Can we lower this so we can take it apart?
Yeah.
Oh man.
This is a boiler pump. All right. So when I'm going to put it back up so you can see better. Okay. Whenever this boiler is engaged, whether it's to heat the house or provide hot water for domestic hot water, that pump is on. What that pump will do is that pump circulates the water through this circuit. You guys see this circuit? This is a circle. Goes then through the heat exchanger and keeps circulating. That is the only function of this pump, is to keep the water flowing through the heat exchanger so the heat exchanger doesn't overheat. Now, this will provide no heat to the house at all. For that, you're gonna need a second pump out here. Now, if you notice, this pump arrows towards the boiler. So, if you see the water flow, this is from the radiators, comes down through here. Some of that water will go up to the heat exchanger and come back down on the supply side from the boiler. Some of it will go straight through. They will then mix right there and continue moving on to the radiators. So what you're gonna have is 100, let's say, 100-degree water coming here. Half of it will go up to get heated up because this pump will draw it up to the top. It'll come back really hot here, like at 180 degrees, mix with 100-degree water, and it'll come out as 140. Bear in mind, as the boiler keeps working, the water keeps coming back warmer and warmer from the radiators. At some point, you have 160-degree water coming back in, mixing with this 180, you're coming up at 175, right? Because as the water comes back warmer, the mix affects it, makes it warm. So again, this is very important to understand. The pump inside, it does this circle. The pump in here does this circle. And they mix through this, and they refer to this as a close set of T's. T's that are close together. That's because this is the mixing point of the water. You understand, Rich? Mm-hmm. Good. So that part is hard to understand, but once you get it, it makes sense to you. You always have two pumps, right? The pump that's circulating the water through the boiler, and there's a pump that takes the water and brings it from the radiators, from the copper fin tube, from the hydronic coils like Vasil and all that I'm working on right now, you know? Brings the cool water in, mixes it with the water from the boiler, warmer water goes out to whatever we're trying to heat up. As far as the controls are concerned, you know, that's something to report. So that's just piping. Also, along with this, every boiler is going to have a water feeder, it's going to have a gauge, it's going to have a pressure tank to maintain the pressure.
The pump
Right.
could be on the supply or the return.
Good question. Yes, the pump could be on the supply or on the return as long as the direction of flow is correct. So if you have this pump sitting here, then this arrow cannot be to the boiler, has to be away from the boiler. Right. Because you can pump away or feed to the supply, or you can pump back into the boiler on the return. Either one is okay. You know, either one will function. It's just important not to buck the two pumps. Meaning you don't want the pumps pumping at each other, you want them pumping along, right? Because this pump, as it pushes through here, it'll assist this pump, and when this pump pushes the hot water back through the heat exchanger, it'll also assist this pump. Does anybody have a marker?
Yep, here you go.
I'm gonna draw this.
So everybody just
down, right? And here, arrow like this, an arrow like so, right?
Slow.
And this is literally what happens. This will make it clear to you, right? The water goes through here, some of it goes through, some of it goes up on top, comes back, mixes with this water, and goes back at different temperature. I'm also going to draw here 100 degrees, 100, 100. Here's going to be 180, and here it comes out as 140. 140. Right? This makes it. You get it, Eric?
Yep.
Who did I take this from? Peter? Tom? Sorry. All right. Controls. This is something that it's important to remember. Every boiler for heat closes on X and X. So the power from the boiler is provided usually on this little Muller's plug. And all you do is when you close this, the boiler comes on. It does all the work for you. It turns on the pump, it starts up the inducer, it fires up the gas, turns on the the gas valve, all of that. So if you do this, the boiler comes on. It's important to remember because a lot of times what we're going to do is we're going to control this with a thermostat, right? So this goes to like a R and a W on a thermostat, right? You see that all the time on your thermostat. That could be thermostat, standard thermostat. But you can also turn it on differently. You can take it to a control board and notice on this control board, I'll have you guys look at it later, there's an X and X set right here. X and X. And that's basically for you to connect these wires to this set of screws, because this will then act as a thermostat, and basically this will do this. It just makes the connection. You guys get this? So you close this with a wire nut, the boiler comes on. You close this between R and W on the thermostat, the boiler comes
So
on.
can't you not actually apply 24 volts to the XX and not the NTI?
You cannot. So this is a DC signal. So you cannot, this needs to be closed, but all traditional thermostat is RW with its own battery, will close it, So just remember this is a DC signal, so this is not like your furnace per se. But you remember, all you're doing is you're closing these two wires to fire this up. So that's why you're gonna see on all these control boards, like you got a control board for zone valves instead of pumps. This is a pump control board, right? But you can also have different zone valves. So when you have something like this, you're gonna have these X and X. You're gonna have a 2-wire go from X and X to this, and that's what basically fires up the boiler. Unfortunately, there's no water in the boiler, so I was gonna start it up, but it just gives me a pressure code because it realizes there's no water in it.
So what is sending the signals to the zone board?
So this is like that good question. So now we know now that to turn the boiler on, we're gonna connect 2 wires from X and X here to X and X on the control board. And all the control board is gonna do is what I just did with the wire nut. Close it to start this up. Now here is your traditional, looks like Honeywell, Calafi, this Sony, whatever control board, they all do the same thing. What they have is a section towards the thermostat, section towards the pump, plus X and X for the boiler. So remember those 3 sections. X and X to the boiler, the thermostat controls, and to the pump. So you're gonna see R, W, and C for each thermostat. So from here, you're gonna go to an individual thermostat in someone's house. Let's say a basement zone. Basement zone is gonna connect to these 3 wires, or 2 of them, R and W, Whenever the thermostat calls for heat, it'll close between R and W. And what's gonna happen is this control board here is gonna engage 2 relays. One of these relays right here will send 120 volts to pump 1. That's gonna send power to that pump, let's say, right? And it's also gonna close this relay here so that this can happen and the boiler will come on. If you have more of these zone valves, then more pumps will come on, but at the same time, the boiler also comes on because these are all piped and connected parallel. There's something very important Taras and I discovered on a job over at at the gay guy's house in Magnolia. Cut that out.
Leave it.
Why?
Taylor, cut that out.
He's like, man, not boys.
At the untraditional household at Magnolia.
Yes.
Over there, this was good. I'm glad that Taras found that, and but you learn things from mistakes. So anyway, a lot of these controls have a primary pump, and the primary pump is designed to connect to heat up a storage tank, basically to engage a pump that heats up a storage tank. And if there's usually a switch that tells you if pump one is a primary pump, or there's a separate one for primary. This one actually is a little different. This one is separately done here, which is better. The other one had 1, 2, 3 pumps, and one was primary, and there was a dip switch that was meant to be turned off if you don't want it to be a primary pump. Now we didn't do that, and the result was this. If this thinks you have it connected to a hot water tank, it will not turn on other pumps until your primary pump is satisfied, because it's thinking someone's taking a shower and you gotta make sure that you have hot water going to the storage tank, and you really don't care about heating someone's house until the hot water is satisfied. So that's a big problem if you're not using it in such a way, because then the other pumps do not get turned on. So if you have a control board like this, check for primary pump. And by the way, Vasa, you should check on yours to make sure you don't have to set up for primary too, because you might on the zone panel that you have. And you don't want it to happen, because what's going to happen then is you're going to have 3 air handlers trying to work, and only one of them will be working until the temperature is satisfied over there. I'll explain it to you in Polish if you want to hear it. Just makes sense. So very, very basically again, and you know what? I'm gonna make sure that everyone gets a chance to install high efficiency boiler, and everyone gets a chance to really do this.
Yes.
And it'll make it easy. So you're learning this right now, Eric. Tomorrow you're gonna basically finish all this up, and we're gonna draw this again. But the important thing to remember is this: the new boilers will have a pump inside. That pump is there to circulate the water throughout the boiler. There always needs to be an additional pump outside. This pump is not enough to heat the house. It's only for this circuit. This circuit goes through here, mixes the water, and mixes some of the cool water returning, right? On this, remember, X and X or T and T are the two things that engage the boiler. Either they get turned on by a thermostat, or they typically will go through a pump control. So this will turn on, so you basically, if that happens, you have an X and X terminal that connects right to here. They'll engage the boiler for you at any time. Any one of these zones is engaged by their own individual thermostats. Do you guys have any questions?
Where are we gonna put that tank at?
Okay, so good question. This